Hello, and thank you for watching another OpenTopography tutorial. Today we'll have a short video that will show you how to take a digital elevation model we get from the OpenTopography website, add some additional layers to it in Qgis, and then have it ready for a 3D print. The first thing we need to do is go to the OpenTopography website at opentopography.org and find the digital elevation model we wish to use. You can search up here in the top right for a specific location, or if you want to browse, we can simply go to Data, Find Data. Today I'm going to work with a portion of the San Andreas Fault called the Dragon's Back. So this map pops up after clicking Find Data, and I'm going to scroll into my site that I'm interested in. So this here is known as the Dragon's Back. I'm going to select the region I wish. Notice the red is only where data exists, so outside of this red box I will get no data for my DEM. I'm going to scroll down and choose. Here I have a couple of selections, this Dragon's Back project or from the B4 project. I'll choose the B4 in this case and click Raster. See, my selection is still valid. Scroll down. I want my data output format as a GeoTIFF. Right here in step 3 I want to have a digital terrain model, or DTM. And then this will be nice. I can generate a hill shade that'll pop up so I can see what I'm working with. So I need to go ahead and label my job. I'll call this test. Give it a description, also a test. And I have an account here, so my email automatically populates. It'll send me a notification that the job is done. Additionally, I can process larger data points because I have an account, and click Submit. It takes just a moment here. Actually, while we're working on this, let's go over to QGIS. Welcome to the QGIS project. Perfect. For this tutorial, I downloaded version 3.10. I like to use new models. It works for me. Perhaps you can follow along with older versions if you already have them on your computer. But the idea is we're going to keep this completely open source, is why I'm using QGIS rather than ArcGIS, for example. So maybe start your download process for QGIS if you don't already have it. And let's go return to OpenTopography. You see our job is done. This is that hillshade we chose to display, so I can visualize before I proceed what exactly I have downloaded. And then now I have my DEM results and need to download this Raster's sdem.tar.gz file by simply clicking it, and the download will begin. Now let's open up QGIS and get our digital elevation model loaded. Mine is still in the downloads folder, so I'll go to my C drive, find myself as a user, Tyler, scroll to downloads, and in this case I'll use the output.tin.tar.gz. Yours may show something else, and just drag it over and drop it. Perfect. There is my digital elevation model layer created down here in the bottom left. And now we need to go to plugins at the top to get the software that's going to convert this to an STL, which is a 3D print file. If you already have a mesh or an OBJ file, perhaps from some SFM products that you've done, you may wonder why you need to go through this step to produce an STL file or an OBJ file if you wanted. And that's because you need to add a base to this 3D print model. In my experience with terrain models, if you don't have a platform of some sort to print this terrain off of, then you will get some voids in the lower topography areas because there's no base to print. So essentially we're going to put a border or a platform to which we're going to print this model on, and simultaneously create an STL file, which is favored by 3D printers. So at the top we'll click Plugins, go to Manage and Install Plugins, and then up here in the search bar you can simply type 3D, and you'll see this plugin pop up called DEM to 3D. Click it and you can read a little bit about it, but we'll just click Install Plugin. It's very quick, and now we'll close. Another point to mention here is this is going to produce about a 500 megabyte file when I convert to an STM. So one thing that you could do is chop this up into pieces, or perhaps you only want to 3D print a section of this digital elevation model. Then you would go up here to the top and click Raster, Extraction, clip raster by extent, and you get this little dialog box. Really all you need to do here is click on these three dots next to the clipping extent and select extent on canvas. Now you get the little crosshairs, and if I only wanted to print maybe just an arbitrary box, I could select this, and now it's calculated my X and Y data, and I'll click Run, and then I can close it. And as you see down here on the left, I now have this clipped extent, and I could use this as my print file. Also, if I did this and maybe chopped my DEM into 3 or 4 pieces, I could reduce the file sizes to make managing them a little bit easier, and then later we could merge them back together before printing, which we'll get to. So now I'm ready to print this, or get this ready for print. We'll go back to Raster at the top, and now you see this DEM to 3D. That is the plugin we downloaded, and come over and click DEM 3D printing. Up here is whatever files you have loaded. So in this case, the clipped extent, if I wanted to print just that, or the output, the entire digital elevation model. Then you need to plug in the X and Y's once again for the area you want to print. But if you click these little crosshairs here, select layer extent, you can choose again based on your files down here in the bottom left, and it'll automatically crop to which file you select. So you'll see a red box pop up, and this is essentially the border of my platform that I'm going to be printing off of. Down here you need to come into spacing. There's a 0.2 millimeter minimum requirement, and I've tried these, and it seems it gets a little bit more grainy as I go to higher spacing values. So I'll choose 0.2, but again, to maybe reduce file size, you could go bigger with those numbers, or depending on what you're printing, larger numbers may work better. And then you need to select the width or the length of your model, so it's in millimeters. So I want a 10 centimeter wide model. I'll choose 100 millimeters in width, and you can see it automatically scaled my length. Then we come down to the exaggeration factor on the vertical exaggeration. I do not want this model vertically exaggerated, so I'll leave this value as 1. And then I need to choose the height for my base. And what that means is it's going to be relative to the low point of the elevation of my digital elevation model. So if I choose my base height as 0 meters, and the lowest point of my terrain is 653 meters, that means there'll be a 653 meters scaled plateau from my platform to then my model. So it means that my model will be raised up on this aggressively large plateau. So if I choose, which I've done practicing, 650 meters, for example, and have the base be just below my terrain, it actually looks as though some of the terrain sort of disappears into the base. So I found for this case, choosing 600 meters and leaving a 53 meter window between the base and the model, it gives me good results. And then I'll click here, export to STL. Give it a moment. We'll just save this back in my downloads. And the most important part here is that whatever you name it and wherever you place it, you put a .stl at the end, even though you're choosing the STL file. This could be the version of QGIS I'm using, but it won't work unless I put .stl there. And I'll click Save. And then it takes a few moments to process this data and create my STL. Okay, now our STL model has been generated. Just click OK. You can cancel out of here. And now we're done with QGIS. And let's go see what we've done. So if I open up my downloads folder, you can see I have this 3D object. That's good. So I can right click, open with, and Windows has a 3D viewer built in. Let's try this. So here's our model, and you can see it's created this square or maybe rectangular platform. And this is a little bit of that plateau effect I was talking about, more visible on the high side, but then you can see on the low side your terrain sort of still disappears slightly into it, but that was basically by changing the base height in our export options that gives us this, and I'm happy with this. This looks nice. So now you have that STL file and you're ready to print. But quickly I want to go into a software called Meshlab. So Meshlab is also free to download. It's a nice visualization software for this, and you can also merge these STL files together. So if you would have gone the route where you split up your digital elevation model into a couple more manageable file-sized STLs, you could then bring them in here and merge them into one STL for a single print job, or you could perhaps merge buildings onto topography, or bring in some sort of cartoonish mesh and merge it to your terrain. So we'll go in the top left, import mesh. In my downloads, output model, it's an STL file. Just click OK here. And now we can see our mesh once again. And the visualization here is pretty nice compared to the Windows software, but you can do more to your mesh. But again, if you don't need to take any additional steps after the export, you can view it in the Windows viewer and then that file is all you need to print. So before we would have had some problems if we had just had an STL without adding this base to it, but now that we have this platform that we can print our digital elevation model on top of, everything should be good to go. As always, thank you for watching another OpenTopography tutorial.